Very much, Sven. It is a pleasure to be here. You know, the last time I was in presence at Eurosymposium Health Aging was 2012, where pretty much a lot of the longevity movement started with our joining of forces. And yes, my focus is on activism, but I'm also involved in research. I have over 70 academic papers, book chapters, articles, uh, 2 books. And you consider part of it concerns, as you mentioned, attempts at mathematical modeling of aging-related diseases. I'm not a mathematician, not a data scientist, not a programmer, but I have some vision, some common sense, and I cooperate with data scientists, with programmers, especially with Dr. David Bloch. And together we co-authored about over 15 papers on computational biology and medicine of aging. I'll touch more on this research. And also recently we published, this book, AI for Health Longevity, Artificial Intelligence for Health Longevity, where I was quite helpful in making sure this book is published and not buried somewhere. So also very proud of it. When the co-editors were, let's say, Moskalov and Alex Zhavrenkov. So I tried to do my best to advance this area of research as well, and that's how I earned my place here at this conference. But once again, I'm not a mathematician. I was responsible for biological interpretation for the general overview and promotion. So first, let me start. Why do we even need AI for health longevity? In this audience, there's no need to explain that aging is the main underlying cause or risk factor or disease itself that brings about most of ill health in the world. So if we are really serious about prevention, about extending health longevity, we have to fight aging as a main factor. That's the axiom, the main premise of geroscience, of longevity medicine, of our whole movement. And I'm happy that also through our advocacy, and many people here were involved, Sven and Didier, we were actually able to include aging as a medical condition and into the ICD. Not as a disease per se, but people still afraid of semantics, but as a causality category, as an aging-related code, and as a general symptomatics category. The aging-associated decline in intrinsic capacity, much of it was done thanks to also our advocacy, specifically of International Longevity Alliance, or Gerontology Research Foundation. Myself personally went with this issue to the Israeli government in 2012 and asked, wrote a letter to all the 120 members of Knesset, asked that aging is recognized as a disease. So we have been all fighting for this. And now it's in the ICD, in International Classification of Diseases.
Ilia, can you hear us?
Yes, I can hear you.
Oh, sorry, 1 second. Can you hear me?
I can hear you. Can you hear me?
Okay. Yeah. Can you wait for a second? I think we have some issue with the Zoom online. Just a pause for 1 second. We will quickly check and I will give you the cue to start again.
Yeah,
Sorry.
okay.
We will just start Zoom again. Thank you.
Right.
Can you go
Ilia, can you hear us now?
I can hear you always.
Okay.
Where did I stop? Where should I go?
We did not hear anything about the ICD-11 for mortality
Wait.
slide.
All right. So I go
Wait,
back.
wait, just 1 or 2 minutes more, because I don't know if it is online or not. You see it? When I was giving the YouTube link online, can you check on it?
I'm checking right now. Let me see.
Try,
Yeah.
just 1 minute more.
Can you still try to?
Yeah. Okay.
Yeah, I see my slide, and
Okay.
so it should be good.
Oh, no.
Yeah, I see it and I hear you.
Yep. Next one is.
Now, let's see.
Yes. Where is your?
Yeah,
Where is
it's on
your?
YouTube. It's showing. We're talking on YouTube, so it's good.
We have to find where is the.
Just lift it and see.
Okay. Continue to speak.
All right. So the point I was making, it's a common position of the entire longevity movement. I would say that if we really want to extend healthy life, to fight pretty much all the diseases, to fight mortality, to fight death, we have to address aging as a medical condition. And I'm happy to say that also thanks to our advocacy of our organizations like International Longevity Alliance, Biogerontology Research Foundation, also the work of many people here, Sven and Didier and others, aging is now included in the International Classification of Diseases as two types of categories, as a causality, as an etiology, the so-called aging-related code, and as a symptomatics category, the so-called aging-associated decline in intrinsic capacity. Yes, aging is now recognized as some kind of medical condition, not as a disease, because people still afraid of semantics. But we can address aging now, and that's also part of our advocacy. Also from Israel, I wrote to all the 120 members of Knesset back in 2012 and requested that aging be recognized as a medical condition. Maybe also mute, I don't know, some noises. And then all together through all our joint efforts, it's there. And why, even though it's in the ICD-11, why don't we have a massive influx of anti-aging testing, and anti-aging therapies, because the argument was if we recognize aging as a medical condition, it will open the gates of heaven for the anti-aging industry. It didn't happen so far. Why? If though we have all those proofs of feasibility, all the famous classifications of aging processes and proofs that we can intervene in this aging process, such as strategies for engineering negligible senescence. And after that, the hallmarks of aging, the most cited paper in biology of aging, and also the NIH pillars of aging. They all have the same idea that yes, there is a certain major aging process that we can intervene into and extend healthy life, and there are rules of feasibility for every one of them. At the animal models and also some human trials. So how come we were not moving into the massive clinical testing of anti-aging? And I would argue that part of the problem is that we don't have reliable metrics of aging. We very simply don't know how to diagnose aging, how to measure, first of all, aging as a process or as a state, as a predictor of aging-related ill health, and also as a measure of effectiveness and safety of supposed anti-aging treatments. Obviously, everything changes with age. Absolutely every parameter in biology changes. So basically, everything can be a biomarker of aging. So once again, we get to the problem of complexity, but also the problem of selecting what biomarkers are actually useful in economic terms, in medical terms, what are the most informative, predictive biomarkers, but also what are the most economical biomarkers. Obviously, we cannot measure all the reactions in the human body for all of their lives, so that should be economical. And we still don't have such agreed metrics that would be evidence-based. And I argue that a major part of this problem why we can't proceed toward massive anti-aging testing and treatment. And that's also a problem of regulation. Many people are scared of the very word regulation, all kinds of association with bureaucracy, right? But we need some basic common principles. How do we measure aging? How do we measure its predictive capacity, to predict disease? And also, how do we measure the anti-aging treatments. Effectiveness, it's needed for two reasons. Basically, we need to encourage the treatments that do work, and we need to, kind of filter out the snake oil treatments that don't work and may never work. As an historian of the field, I can tell you, and you probably know as well, that there was no shortage of snake oil remedies that promised amazing results. But all of them failed simply because we didn't have a way to measure the effects. We can promise anything, but you actually have to show some metrics that show that it's working. Here's where I believe the question of computation, the question of artificial intelligence comes in establishing those evaluation criteria for aging, both as a diagnosis as an evaluation of therapy. And it's not an easy task, absolutely not an easy task. There are many confounding factors. I published back in 2017 a paper recognizing degenerative aging as a treatable medical condition, which includes some of the cans of worms that we need to open and deal with in developing evaluation criteria for aging, which includes the basic clarity of definition. Can you believe it? We don't have the basic definition of aging in clinical terms. Is it a syndrome, the polysyndrome, risk factor, underlying cause? Is it a process, is it a state? We don't have the most basic agreed definitions. And there are also the multiple confounding factors. The problem of translatability from animal models to humans. The long-term consideration, obviously, things that work now may not work for the long term. We still need to show that certain treatments work on older persons. We all talk about prevention. Anti-aging is preventive treatment, and it would be great for the economy, etc. But how do you show that these treatments that are given young age are actually beneficial for old age? You cannot wait for decades. And if you rely solely on biomarkers, there's also no guarantee that you'll have any benefits. So huge the battery of cans of worms that we have to deal with, but we have to deal with them. We have to encourage this discussion also through consultations like this. And in this regard, also the complexities of AI come in. AI was supposed to help us calculate all those evaluation criteria, help us develop the metrics. But in addition to the uncertainties that I mentioned earlier, there are also many uncertainties with the use of AI. So sorry if I'm raining on anybody's parade or reducing anybody's will for optimism. But I personally would take many of the AI promises with a large grain of salt, at least at this point. We all know, how can we rely, for example, how can we rely on artificial intelligence when the doctors are incompetent, cannot interpret them? What is even AI? How can we speak about AI without understanding the real intelligence? Usually artificial intelligence is something that mimics or emulates some real phenomena. We don't really have a good idea of what real intelligence is. So how can we speak about artificial intelligence? That means is right now the definition of operational. So these uncertainties are serious and need to be taken into consideration. And also, in basic practical terms, when we try to develop metrics of aging, and this is also the topic we developed with my colleague David Bloch. That's mainly his wisdom, but I mainly concur with him. Is there are many problems with artificial intelligence that can put the results in question. For example, AI, what we understand is AI, like machine learning and neural networks, deep learning. They're mostly ad hoc algorithms. Basically, they're heuristic. So if they were trained, if they work in a certain data set, there's no guarantee that they will work on another data set. If there's no thorough standardization, if we are not sure that the equipment produce exactly the same measurements as in the other data set. So all this can put the validity of this algorithm in question. And also there are other problems that the deep learning cannot probably may have difficult to solve. For example, the problem of non-linearity, also Georg mentioned. the problem of synergy. It could be negative and positive. Some treatments can combine to produce a better effect. That's also what Aubrey is now doing or trying to do with his four-pronged intervention. But some combinations can actually produce negative effect, the effects of polypharmacy. And the measures of information theory can provide some solutions. For that, for example, normalized mutual information that can actually evaluate the correlation between multiple causative factors and multiple results, which could be multiple diseases, and also show synergistic or nonlinear results, cumulative results. Basically, when the sum is greater than with the whole greater than the sum of parts. Basically, if you have a combination of two interventions, you can have a result that's greater than each intervention separately, but you can also have a diminished results. This is allowed by the tools of information theory. Also, it allows to establish nonlinear correlations. Most correlations, if you read most of the papers in biology, they all use linear correlation coefficients, linear regression. But in life, in biology, processes are usually nonlinear. In here also, information theory allows a solution. It does not require linearity, does not assume a Gaussian distribution. And so basically can use any type of data. We mentioned interoperability. So information theory could help interoperability because it can use any type of data, rated data, continuous data, binary data, discrete data, and also it is a measure like normalized mutual information. It's it doesn't have dimensions, so it can be used in any type of data with any dimension. So all this advantages of information theory that we try to promote by our research, and also basically what's AI. Basically, the goal is pattern recognition. So we use this metrics to predict diseases, to predict patterns of disease. So that's our contribution, our brick in the wall of aging research. It's there, it's published. Everybody's welcome to take it on board. For me, this direction of research pretty much stopped at the moment. There's so much time and effort I can dedicate to it without any funding, and also my colleague. Another reason why this pretty much stopped for me was that our main programmer, Joseph Gittards is his name. He was pretty much responsible for the programming of all those models. He was killed in Gaza in battle. Brilliant young scientist, a great promise. He was killed. Now we are trying to establish a foundation. His name, but in terms of computation, it stopped. But what I'm saying is that even though I'm pretty much out of it, but it shows you it's an indication that it's not so simple with the use of AI. There are many underlying stones and underwater stones that can shipwreck any attempt of using AI. And also based on our research and also based on combining with other research, we published this book, Artificial Intelligence for Cell Longevity. Once again, I helped that this book is actually published, not discarded. There was a chance of that, and it includes the main topics like biomarkers of aging, use of AI for biomarkers development, also some perspectives and challenges like quality of data sharing, and it also includes our chapter. Pretty much what I said earlier is in our chapter. Welcome to read it. I can even send it to you. You don't have to read it now. Just listen to me. Just to say that all I'm presenting now is on record. It's written black on white, and all those problems with AI that we mentioned directly. That we cannot speak, probably difficulty speaking about artificial intelligence. We don't know what real intelligence is, and we need theory-based methods. Like we're speaking about information theory, but deep learning and neural networks are not theory-based. And some people don't even understand the difference between operational approaches and theory-based approaches. it's like in the past we built carriages without knowing the laws of Newton, but with the laws of Newton, with the theoretical basis, we suddenly started to develop cars and went to space. So the theory has advantages, but most approaches don't even realize the importance of theory-based approaches. And the other advantages that information theory can provide, like evaluating synergistic effects, interoperability, nonlinear relations. So all this is now a chapter. Welcome to read. And I'm coming to Israel. I don't know how much time I still have, but very quickly coming to Israel. I'm from Israel, so all this that I'm reporting now is from Israel. But more generally, the situation in Israel, that Israel has a huge treasure trove of data. Israeli health maintenance systems, HMOs, which we have 4, Clalit, Leumit, Meochedet, Maccabi. They have massive amount of data, electronic data, because Israel was probably one of the first to use electronic medical records since the 80s. So here we have medical data on people for over 40 years, which is unprecedented to establish longitudinal relations. Very important. Many studies of biomarkers are correlational. In the same time, you compare old people with young people, but here in Israel you can have longitudinal data, longitudinal analysis on the same people, how they change with time. Didier, you mentioned TAME. Basically, we don't need TAME. We don't need this study to estimate the effect of metformin on 3,000 people. We have all those data in the Israeli medical records. Millions of people received the metformin. We can do any correlations you need. All this data is there. So that's the big advantage of Israel in terms of and health data. And there are already emerging some attempts to do exactly this kind of longitudinal studies to establish biomarkers of aging. I wouldn't say they're very useful, but at least they're emerging. But still, there's a problem of data sharing. There's a problem of data sharing. Let me tell you also a personal story from personal experience. Back in 2016, we wanted to establish a Israeli National Registry on aging, all the kinds of data of the Ministry of Health in relation to aging that you could find, and then went for it. But then there started problems with data sharing. On the one hand, the Ministry of Health wanted to take all the algorithms from the researchers and use them anyway they want. On the other hand, they weren't willing to actually allow them to download the data. So the human nature, take as much as you can, and give as little as you can, and in the end it didn't go through. But and also every HMO, health maintenance organization, wants to keep the data for themselves, to publish paper, to get more grants, more prestige. So there's just the simple human unwillingness to share data, but we have to somehow overcome it to convince people that it's not easy. It's easier said than done. But still, the effort, there was recently established the so-called Mosaic project that is supposed to coordinate all the sources of medical data in Israel. And that's the recent paper in Nature of Aging. Once again, I wouldn't say it's very useful. For example, they try to distinguish between aging and disease. It's like it's 2 separate entities, but at least there's some start on this activity. And as an activist, as advocate, what I can do is I can try to influence policy. Once again, encourage the discussion of regulation of policy. And for example, we were able to include the topic of health and longevity, research, development, education into the Israel National Master Plan on Aging. It was published in 2019, and one of the major topics there was developing evidence-based metrics of aging, exactly for that purpose. And practically what we did, we helped also through this programmatic document, we helped to issue calls for research proposals within Israel, and also in cooperation between Israel and other countries, like the BioRx Aging Program, the Britain-Israel Research and Academic Exchange on Aging, where I wrote the call for research proposals. And we put there also a very clear emphasis on developing metrics of aging, including AI. So I believe, at least for us as activists, calls for proposals is the way to go. Just issue some funding for researchers to compete, let all the flowers bloom with the right emphasis. Not rely on your project, on somebody else's project, but help the entire ecosystem develop. I believe that's what we can do as activists, as advocates in Israel, at the European level. As you know, Israel is a full partner in all European research and development projects. It's called a partner state in EU, so anything can be done that can be done in EU can be done in Israel or in cooperation with Israel. So that's how we want to advance it. And practically, I told everybody already that we're trying to find matching for another binational international program with Israel. Part of the funding is from the Ministry of Science, and we're looking for the other part. So there you can also build in all the emphasis you want to build in on AI, on data sharing, on openness. I believe calls for research proposal is a very effective way to encourage the longevity field. And of course, we should not forget that Israel is a part of the Middle East. It doesn't feel like this right now when we have hundreds of rockets showering on us. I hope there isn't an alarm right now that they have to stop this talk. But generally we're part of the Middle East, and the Abrahamic Accords are still in the working. The moment it stops, I believe it should stop in a few months at least. We can renew the cooperation with the region. Obviously, the countries like United Arab Emirates and Saudi Arabia have much more resources for this, and they already started programs. You can see, for example, in silico medicine, already actively cooperating there, and many people, like Victor also went there and were impressed what they can do. Evolution, of course, also has a strong emphasis, and I hope when the situation improves with our conditions, we can cooperate and really create a massive synergy. I even wrote a paper about 10 years ago, The Pursuit of Longevity, the Bringer of Peace to the Middle East. Not exactly AI, but I believe that, longevity is one thing that can promote peace in the region. Also computation tool. And of course, this can be scaled up to any dimensions because it relates to everybody. So that's what I wanted to share with you. Happy if there are any questions.